Welcome to this presentation on frameworks for cyber risk management. I am Kalpit Sharma, a doctoral student from Indian Institute of Management, Lucknow, and this work has been undertaken in the supervision of Professor Arunabha Mukhopadhyay. The agenda of this thesis proposal consists of three major studies. First, cyber risk management in massively multiplayer online gaming industry. Second, cyber risk management in smart cities. And third, cyber risk management for autonomous vehicles. Cyber risk management model consists of two major modules. First, estimating the likelihood of a security breach, and second, estimating the impact of that security breach. Once we have these two quantities, we can devise novel and appropriate cyber risk mitigation strategies for the said context. The first study deals with DDoS attacks in gaming industry. DDoS attack or distributed denial of service attacks are a class of cyber attacks in which an attacker overwhelms a web server by flooding it with illegitimate requests originating from a large number of different IPs. Genuine users of a firm are thus denied access to firm's cyber resources. Online gaming industry is the most targeted due to its large and growing customer base in recent years. Gaming sites incur huge traffic during frequent gaming competitions, thus making it easier for attackers to masquerade the dummy traffic. Users also engage in high real-time financial transactions during game use, which increases the target value for attackers. In this study, we tried to investigate four research questions. First, what is the probability of DDoS attack? Second, what is the best statistical approximation for probability of DDoS attack? Third, what is the expected loss for each attack? And fourth, what are the appropriate ways to mitigate the risk? In the second study, we do the same exercise for smart cities by using a time series approach. As evident from this diagram, a misuse of sensors or any tampering with sensors can give a false indication of a traffic in a smart city. So, taking a note from this context, we use the example of integrated traffic management system in smart cities. As evident from this diagram, any sensor, if it malfunctions, can show an overcongestion at a certain path or an undercongestion at a certain path. It can result in traffic jams or even in accidents where it have underreported the traffic volume. In the proposed model, we try to investigate three major research questions. First, how smart cities' resources can be compromised by hackers. Second, what is the impact of these compromises on a smart city? And third, what are the ways we can mitigate such cyber risks in a smart city? The third study deals with cyber risk management for autonomous vehicles using machine learning. Hackers can tamper with electronic speed limit signs and cause the autonomous vehicles to either underspeed and cause congestion or overspeed and cause accidents. In this context, we try to investigate three research questions. First, how autonomous vehicles can be compromised by hackers. Second, what is the impact of cyber attacks on an autonomous vehicle? Third, what are ways to mitigate such cyber risks on autonomous vehicles? Thanks for listening to this presentation, and I would love to receive your feedback and questions.